In this session and the following sessions, I'm going to cover t-test and analysis of variance. We call that ANOVA using f-test. These two are under the umbrella of bivariate analysis, meaning there are two variables, only two variables in your research. And just for clarification, there are more than these two tests under bivariate analysis. Depending on the types of variables, you can think of chi-square, gamma, or correlation. Both gamma and chi-square use two categorical variables. Especially when you have two nominal variables, you can try chi-square. When there are two ordinal variables, you can try gamma. And when you have two continuous variables, you can try correlation test. So what are these two for? T-test and ANOVA. That's when you have one categorical variable and one continuous variable. And the difference comes from the type of categorical variable. When your categorical variable has two values, only two values in it, then we call that dichotomous variable, and you can use t-test. A typical example would be gender. How many values or categories or attributes can you think of? Well, again, in statistics, values, categories, or attributes, they're all same. So, going back to gender, how many values can you think of? I can only think of two, male and female. So, gender is a dichotomous categorical variable. Another example might be ever use of cocaine. A typical format of this variable would be, have you ever used cocaine? And then the answer should be either yes or no. So there are two values, yes and no, under this categorical variable of ever use of cocaine. So ever use of cocaine is another dichotomous variable. So when you have dichotomous categorical variable with a continuous variable such as number of traffic tickets, then you can try t-test. On the other hand, when your categorical variable has more than two values or three or more values, then you can try ANOVA. A good example might be race. How many values can you think of? I could come up with white, black, Latino, Middle Eastern, Asian, and others. So your categorical variable is multinomial. Then you can try ANOVA. And both t-test and ANOVA use the same system. They both use measure of central tendency, which is mean, and they both use a measure of dispersion, which is standard deviation. So these two statistics are the most important factors in t-test and ANOVA. So a broad description of these two types of bivariate analysis might be it examines mean difference in continuous variable across categories under categorical variable, and it tests the significance of this mean difference with standard deviation. A brief description of t-test would go like this. You have a data set, you break it down to the categories under this categorical variable. So if you use this gender as an example, then you break it down to a male subsample and female subsample. So for male subsample, you can actually calculate this number of traffic tickets, mean of it, and standard deviation of it. So you get the mean number of traffic tickets for male subsample and mean number of traffic tickets for female subsample, and you can get standard deviation of number of traffic tickets for male subsample, and you can get standard deviation of number of tickets for female subsample. So using these four statistics, you can actually do the t-test. Basically, it looks at the difference between these two categories in terms of number of tickets. So it's going to be the difference, and then you use standard deviation, this and this, in testing the statistical significance of this difference. And I'm going to elaborate on the mechanism and t-test in the next section.